Hello mathematicians, we're now going to have a look at what are called definite and indefinite quadratics. Now this is really just a case almost of adding a bit of terminology to stuff that you know already. So a quadratic is definite if it has no zeros, and it can either be positive definite if it's always positive, so that's this case here, or negative definite, so that's this case here. So clearly, as we've seen before, this means the discriminant is less than 0, but the coefficient of x squared, a, has to be positive, greater than 0. And likewise for a negative definite. Now its quadratic is then indefinite if it has at least one 0. And you've probably already picked up that the words make perfect sense. This is positive definite because it's definitely positive for all y values. This one is indefinite because it has a value there of 0, and 0 is neither positive nor negative. So if we have one root but a is greater than 0, it's indefinite. If we have one root and a is less than 0, it's still indefinite. And if the discriminant is greater than 0, then again, regardless of the value of a, it's indefinite. So this, as I said, is really just a matter of terminology. So let's have a look at what this looks like in problems. So for what values of k is this parabola positive definite? So if it's positive definite, we need a to be greater than 0, which it clearly is, and we need the discriminant to be less than 0. So actually write that down, require a greater than 0. It's all good, and the discriminant to be less than 0. And that shows the examiner that you know what you're working with. Probably a tick is not very formal. Might be best to say a equals 3. And then the discriminant is b squared minus 4ac, which is 6 squared is 36 minus 4 by 3 by k, so that's 12k. That has to be less than 0. So that means that we want 36 to be less than 12k, which gives us 3 less than k, therefore k greater than 3. And that's our solution. As long as k is bigger than 3, this parabola will be positive definite. It won't have any roots. For our next one, for what values of a is this quadratic positive definite, negative definite, and indefinite? Now, I might not go through all of these. Let's just do the negative definite. So if it's negative definite, that implies a is negative, a is less than 0, and that the discriminant is less than 0. So let's have a look at that. So a less than 0 is no problem. The discriminant is b squared, which is 64 minus 4ac, so 4a times a, so minus 4a squared. We want that to be less than 0. So if I multiply through by a negative just to make it look tidier, oh no, I won't bother doing that, there's no point. So if I take 4 out as a common factor, I've got 16 minus a squared less than 0, which is 4 outside of 4 minus a, 4 plus a is less than 0. So I'm talking about, again, a quadratic. This itself is a quadratic, and it's a quadratic which is concave down, and it will have zeros at plus 4 and minus 4. So it will look like this, plus 4 and minus 4. And the reason for sketching this up is that I want to know where this particular quadratic, which is this parabola, is less than 0. So that's for values of a which are going to give me that part of the curve and that part of the curve. So that will happen where a is greater than 4 and a is less than minus 4. But because I need, so these will give me a definite curve, I need a negative definite, so I need my value of a to be less than 0. So to be less than 0 and to be in here, I'm going to be looking for values of a which are less than -4 as my solution. So have a go at these out of HE. I think you'll find that as long as you read carefully and are careful with your algebra, then there shouldn't be an issue.